Today we're going to be talking about solving compound and absolute value inequalities. So a compound inequality consists of two inequalities joined by the word either and or. To solve a compound inequality, you must solve each part of the inequality. The graph of it is going to contain an and is called an intersection, where it's between two of them. Okay, it's an intersection. So intersections look kind of like this. Okay, so if I'm graphing something that's greater than or equal to -4, but less than 3, okay? So greater than or equal to -4 is this way, okay? Less than 3 is this way. And so then my combined graph starts at -4 with a closed circle and goes to -3 and is in right between them. So that's an and problem. And is between two of them. So there's a couple different ways to solve these and inequalities. Okay? So for example, the first method is to solve each one separately. So if I did that, I'd say 8 is less than 3y minus 7, and 3y minus 7 is less than or equal to 23. Now both of these are pretty simple inequalities for you to solve. You'd add 7 right here. Okay, and so I get 15 is less than 3y. And so then you'd get, divide both sides by 3, and you get 5 is less than y. And then over here you add 7, you get 3y is less than or equal to 30, divide by 3, and so you get y is less than or equal to 10. And so then my final solution is that 5 is less than y, which is less than or equal to 10. Okay? So that's one way to do it. Do each one separately. Now the method I prefer is to actually do them both at the same time. So 8 is less than 3y minus 7, which is less than or equal to 23. Now if that's the case, okay, all I'm doing in this sense is I'm adding 7 to everything. And so now I'm at 15 is less than 3y, which is less than or equal to 30. Okay? Now, to get y by itself, I divide by 3, which means I have to do everything by 3. So I get 5 is less than y, which is less than or equal to 10. You'll notice, both methods give me the same answer, but I would prefer to do method 2. It just seems like less work in my sense. But if you do want to do method 1, that's just fine. Or compound inequalities are known as a union. Okay? And so the way I think of it is boat oars. So if you think of a little boat, okay, you got an oar over here and an oar over here, right? And so the same goes true with your or compound inequalities. They're both going to be going opposite directions, like boat oars. Okay? So you'll see if I have x is greater than or equal to 5, closed circle going this way. X is less than -3, open circle going this way. And so your boat oars are going to be going both ways. So let's look at this one right here. Now this one you can't do at the same time. Okay? This one you're going to have to do separately. So k plus 6 is less than -4. Subtract 6. K is less than -10. And then over here I have 3k is greater than or equal to 14. Divide by 3, and you get k is greater than or equal to 14 thirds. Now, if you're confused at what 14 thirds are, okay, that's going to also be the same as 4 and 2 thirds. Okay. So now I need to graph my solution set. Okay. So I make my number line. Okay. And so I'll start. Here's -10, 9, 8, 7, 6, 5, 4, 3, 0. Okay. All right. -8, 6. All right. So if I look at my first one, k is less than -10. So it's an open circle at -10 and going to the left. K is greater than or equal to 14 thirds. So that's going to be right there, closed circle, and the other way. And so you'll notice when I graph it, it looks like I have my boat oars going out opposite directions. Here's a couple guided practice problems for you to try. absolute value inequalities. Okay? Solving each inequality, graph the solution set on a number line. The letter A says the absolute value of x is less than 3. So that means my distance from 0 has to be less than 3. So if I draw my number line right here, okay, here's 0 right in the middle. So my distance from 0 has to be 3 or less. So from 0, it has to be 3 or less, so it's going to be an open circle there at 3. And it also has to be between 0 and negative 3 or less. Okay? And so now you'll see that my absolute value is between 3 to the left and 3 to the right. So when it's a less than problem, we treat it like an intersection. Less than is treated like an intersection, okay, where it's between two values, like an AND problem. Letter B, this is greater than, and so obviously you can figure out that this is going to be treated like a union. So it's going to have your both ors on this one, okay? Okay? And so I want my absolute value to be greater than 5. So open circle at 5, and you think of some numbers that are going to be greater than 5. Well, 6 is greater than 5, 7 is greater than 5, so my graph's going to go this way. Also the opposite. So open circle at negative 5, and so like negative 6, the absolute value of that is going to be greater than 5. So it goes out this way. So you'll see that less than is treated like a compound intersection, and a greater than is going to be treated like a compounded union, right? Here's a couple guided practice problems that you could try in your notes. So absolute value inequalities go like this, okay? If you have a greater than, it's an OR. So like I said, it's a union. If you have a less than, it's an AND problem. Compound, just like that. So solving this one right here. Solve a multi-step absolute value inequality. Solve the absolute value 6y minus 5 is greater than or equal to 13. So since it's a greater than problem, right here, greater than, it's like a union. Okay? So it's an OR problem. So I'm going to set it up like this. 6y minus 5 is greater than or equal to 13. Okay? Or 6y minus 5 is less than or equal to negative 13. And if you're confused at why the sign flipped, think of it this way. Okay? Back when we multiplied by negative numbers, we had to flip our sign. So if you think of it, okay, I'm going from 13 to negative 13. It's like flipping my sign. It's like multiplying by negative 1. So now I solve both of these. So I add 5 to both sides. We get 6y is equal to 18. Excuse me, greater than or equal to 18. And so y is going to be greater than or equal to 3. Over here, add 5. I get 6 is less than or equal to negative 8. Divide by 6. And I get y is less than or equal to negative 4/3. Okay? Now we're asked to graph our solution on the number line. I'll make a number line right here. Okay? So, we'll circle at 3, and it's greater than or equal to 3, so it's this way. And less than or equal to negative 4/3, which is like negative 1 1/3. So, right there. There we go. So again, holds true. Looks like both ORs because it was a greater than or equal to problem. Here's a couple guided practice problems that you can try as well. Last example we're going to look at. Okay, writing and solving an absolute value inequality. It says Amanda is apartment hunting in a specific area. She discovers that the average monthly rent for a 2-bedroom apartment is $600 a month. but the actual price could differ from an average as much as $225 a month. Write an absolute value inequality to describe this situation. So we go back to how we used to write absolute value equations all the time. We use this formula with absolute value of x minus c less than or equal to the range. So if I'm going to write mine right here, okay, it's going to go like this, okay, absolute value of x minus, okay, and then the average price all the time was 600. The central price is around 600, okay, and it could differ from an average as much as $225 a month. Now, over there I wrote less than or equal to because the reason that is because I want this to be a compounded amount. Not like it's going to be more than $225 a month or less than $225 a month from 600. It's going to be right in between it. Okay? So right here is my compounded absolute value inequality. And so what I have to do now is I'm going to solve the inequality to find the range. So this is you'll see it's a less than problem, so this is like an intersection. So it's an and problem. And remember what I like to do for and problems, what I like to do is I like to set it up so it looks like this. X minus 600 less than or equal to 225 or negative 225, right? And I like to solve them all at once. So I add 600 to both sides. And so I would get, okay, well, negative 225 plus 600 is going to be 375. And 225 plus 600 is going to be 825. So what it's saying is that the range in prices for rent could be as low as 375 or as high as 825. Here's a guided practice problem that you can try right now.